Doing Nat Overload or PAT with a single ISP is easy and straightforward, but things get a little bit complex once you have more than one ISPs terminating on your Cisco router. With a single ISP, we only need an ACL as the matching criteria because there is only one outgoing interface towards the internet. Once more than one outgoing interfaces come up, the matching on ACLs alone becomes a limitation. We then use route maps to match interfaces alongside ACLs to facilitate the NAT overload process. And this is what we will take a look in this lab. Let's begin. The same concept of the dual ISPs that we will perform in this lab can be applied to multiple ISPs. So you may have 3 or 4 ISPs. You could well apply this concept and this method to all of them as well. Moving on to the lab information that we have here, and we will discuss the lab topology with it. First of all, everything except the NAT router configurations on the NAT router, which is this router here, has been configured. So we don't have any NAT statements. We have IP addresses configured here, and that's pretty much it. So BGP is running between the ISP routers for our default route from each ISP. ISP1 is preferred via the wait attribute. Now you could do this differently if you have a live environment. That may be a really different kind of a scenario for you. It really depends. For this lab, what I've done is I've run BGP between the ISPs. So I have a BGP running with ISP1 and I have a BGP running with ISP2. I did that because they will be advertising me a default route, and I'll be getting 2 default routes from 2 different ISPs. And to make it a little bit simpler, because I didn't want it to go into the floating static routes kind of a scenario in which you use IPSLA tracking and then the floating static route comes into play. So I didn't really want to go into that scenario because I need to test a lot of things. So this just makes it easier. And I personally was in this previous company. This exact scenario was over there. Obviously the BGP number and subnets were different, but this scenario existed over there. So BGP is running between them, and then we have these Google servers. Obviously they're ISPs, so they will have an upstream ISP and then an upstream ISP, and eventually they can both reach the Google servers. But check this out. This Google server is hovering over here, and this one too. The thing is, basically, I didn't want to make things really complex here. So what I did is I just created a loopback address on this ISP, which is a router, by the way. And similar with the case with this one. So if anyone does ping 4.2.2.2, the ISP can respond to it because its loopback address has been configured for this specific IP address. And don't worry, they won't overlap because we're basically going for a scenario where we will be using one ISP at one time. You could use both of them in the real world, but the thing is, these routers actually don't do load balancing, they do load sharing, so that's different. But I'm not gonna get into that. So that's pretty much it about the lab. And these are routers actually converted into the icon has been converted into a PC icon so that we can do testing much more efficiently, like trace routes and stuff. So they're much more easier to do. And eventually you only have a CLI in a virtual PC as well. So why not use the CLI of a router if your resources allow you to? So there it is. We got this covered. And let's head over to our lab steps. Alright, the first step is to configure NAT overload the same way we do for one single ISP. And I have written that statement because I want you to see what happens when you do such a thing. Alright, let's go to our NAT router. Here is it. Here it is. Okay, so first of all, let me show you show IP interface brief, exclude and assign. So we got 2 ISPs. One has a 200 subnet, and that stands for second ISP. That is why I have given it 200 IP address. And the first one has 100 configured on it. So what else do we have? We have BGP configurations. If you want to see this BGP configured, here it is. So it's kind of really simple. We have router BGP 10, that is my autonomous system. A neighbor remote AS, that is the ISP1's autonomous system, and this is ISP2's autonomous system. Now, the only difference what you can see between them is the wait attribute, and that is because I wanted ISP1 to be the preferred ISP, so any routes that I get from ISP1 are gonna be given a weight of the maximum. This is the maximum weight, and this is a Cisco's proprietary attribute which we have. That is the weight attribute for the BGP, and that makes it much more preferred than the other ISPs. So any route that I get, so show IP BGP, if I do that, you can see clear enough that this little caret over here, that basically marks the best route that we have. You can see the best route. So the weight attribute is above all of them. So that's up with the BGP. Now, all right. So what else would I need to do? You want me to configure Nat Overload? Okay, I get it. So I was just showing you stuff. Configure terminal. Now there are no NAT configurations. If I do NAT, include NAT, you won't be seeing any NAT configurations on this router. So what we're going to be doing that now, simply we know that for NAT overload to work, simply we have to specify this subnet, which we have on our internal side in an access list. So let's do that. Internet, as we always name this internet. So permit IP 10. What was it? 10.1.1 1.1.0 0.0.0.255 because it's a /24-bit subnet mask and going towards any. I'll just put a deny any there. Don't really need to. No, deny IP any, sorry. IP any. So there it is. So I've got our beautiful access list configured. Here it is. Okay, so that's pretty much it. Now let's go toward the NAT configuration. So IP NAT inside source list, and we go with the name of internet, which we just configured, and we're gonna say if that is the if statement, I mean if they are one of those subnets that we just configured, then you have to do a NAT overload on 0/1. That's the first ISP. Now this gig 0/1 is going towards ISP1, and gig 0/2 is going towards ISP2. So first of all, we configure this overload statement. Now check this out. Show run include IP NAT. So let me just see if that statement is there present in the running config. Oh, one thing I forgot actually is to configure the interfaces as the IP NAT inside and outside interfaces. Now for this lab, this guy is obviously going to be the inside interface because this is where your inside hosts reside, and these two are going to be the outside interfaces, right? So before I go deeper into this, let me just configure them. Gig 0/0 IP NAT inside. It's going to take a little bit of time, which I don't really like because I want to save your time as much as I can. I really was going for doing a pre-lab setup that of NAT, but I just forgot actually. So interface, what was the next one? Gig 0/1 and 2 both are IP NAT outside. So interface gig 0/1 IP NAT outside, and this is going to be the outside part as well. No, NAT outside. Okay, so there we are. So show IP NAT statistics. As you can see, now we have outside interfaces, 2 of them actually now, and this is the one interface on the inside. Now what do we need to do? We need to configure NAT overload, and it's pretty much done if you were working with one ISP. That would have been the if that would have been the case, then you've been you know, like you've done the lab, but not in this case. So what we're gonna be doing, we're gonna be saying, okay, this works for this interface, right? So let's just copy that and just put it over here with the 2 and it should work. But check what happens. Include IP NAT. No, as you can see, it only takes one statement. it doesn't make sense to take two statements. Now, let me just clear that out a little bit. Now, if you have two statements, like you have one statement with gig 0/1 with the overload and one with gig 0/2 with the overload. Now, the problem arises with the if statement or the matching statements. Now, routing is a different process, okay? It's a different container. Routing works fine with this, but the problem comes when NAT is triggered. The NAT statements here don't have a priority or an access list kind of number, okay? Because if you're familiar with ASA or FTD NAT, they have a different order for NAT. Now for the iOS or iOS XE router devices, if you have these two statements, if for instance I would say he would have gotten these two statements in its RAM or its running config, what would happen? Now you are looking at two statements in front of you right now, okay? So the internet, this part as you see, the internet keyword that you see here is referring to an access list, and this is kind of the if statement for the NAT. Now the NAT process gets confused because it's referring to the same ACL. How will it determine that it has to use this statement or that statement? Well, the truth is it can't. And that is why you need to match specific criteria once you have dual or more ISPs in your environment landing on a single router. Now that you have that concept, let's configure efficient matching for the NAT process. So that is done with our route maps. So let's start configuring them. The configure route maps for each ISP for efficient matching. So we're going to be matching on this subnet, which we are already, but that isn't enough, right? So we have to match on this interface as we learned in the route map lab previously. So now let's start configuring route maps. First, we'll create a route map for the ISP1, and I'll name that route map ISP1. Now I'm gonna match based on the access list that we created, and that is the internet. You already may know the syntax. If you're not aware of this syntax, I highly recommend you that you go to the route map lab and go through that video. So matching on the access list of internet, and we're going to be matching on the interface because it's for ISP1. The interface is going to be gig 0/1. So interface gig 0/1. Now this is it. This is the matching criteria we're going to be using route maps for. No set conditions, no need to apply it to an interface. The NAT process would take care of that. So let's create the route map for ISP2. So it's like match IP address. You can refer to the same ACL, internet, right? And match the interface to gig, what was it? Gig 0/2. All right. That's pretty much it with the route maps. So if you were to look at the route maps, you can see this is a route map and we only have the match clause here. So we have the match clause and we have the access list configured and the gig 0/2. This is the outgoing interface that we have matched in this route map. And then we have ISP1 that we have the same access list being matched and the interface is different. So we have a different matching criteria now. So it's pretty good. Let's configure our NAT statements now. Now, it was the third step, right? Yeah, sure enough it is. So let's first get rid of this NAT statement that we have here. Note of that. And then we go for IP NAT. First, let me do a terminal width to like 512 so that it doesn't cut the output like this. Hopefully it won't. IP NAT inside source list. Oh, sorry, list. No more list. Now here you will specify a route map. Now that is a much more better way to match. So as you've seen, we can specify interfaces and IP addresses in route maps. So the rest of the command will be the same. Let me just hit the route maps real quick. So we're doing this first of all for ISP1. So let's get the ISP1 route map, and this is the one. That is the name of the route map. And the interface ISP1 is on is gig 0/1. So gig 0/1 overload. And then we'll configure the same NAT statement for gig 0/2. Just the route map name will be changed because the criteria is changed. As you can see over here, over here the interface is different. It's gig 0/2. So if you now look at the NAT statements, you'll be seeing that both of them are there, present over there. And let's do a check from PCA. First of all, I'm gonna do a ping to 4.2.2.2. Sure enough, it works. Let's do a trace route to 4.2.2.2 numeric so that it doesn't look up DNS for no good reason. First of all, the first hop is obviously our router, our NAT router over here. This is the first hop, this one, and then it should go on this hop. So it did. Okay, so it's going towards ISP1's router, and that's it, because it has that route directly connected as it's a loopback address on both these ISPs, so it doesn't need to go further. So let's do one thing now. Now let's just tear down this ISP as it would happen. So let's go to the ISP1 and say that something went wrong with the ISP. And let me just show you the BGP configuration. So something went wrong with the ISP, and their link is going down. So you could do a real no shot, but there is another way that I really like. Router BGP 100. So a little neighbor 100.1.1.1 shut down. So it's going to shut down the neighborship, and as you can see, neighborship peer is down. Now, if you go to show IP BGP, first of all, you'll see that the default route that was coming from the 200, the ISP2, is now the preferred one. Now let's go to PCA and see if that is working. 4.2, all right, ping's working fine. Now let's do a trace route to 4.2.2, and as you can see, the NAT is happening. If you were to look at the show IP NAT translations here, there are some translations. What is this? Oh, this is UDP. Oh, all right. This is a trace route actually. I was confused. I was doing ICMP pings and UDP. Okay, so these were some trace route packets going through when they were going through the NAT router for ISP1, and this is for this is that trace route that we actually did just a second ago, and the packet, the outgoing interface was ISP2 in this case. So this will work now. So let's just put this ISP back online. So let's say the ISP came back up with its routes and everything, and its neighborship is up. So show IP BGP, if you look at that, as you can see now, ISP1 is preferred, and let's check trace route again. And as you can see, now you're going from ISP1. So that is how actually you configure NAT overload with multiple ISPs, I would say. Not with only dual ISPs, with multiple ISPs you can do that. Well, I hope you have understood this concept, and I hope this has been informative for you, and I'd like to thank you for viewing.